Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over how you determine the precision and range of a measurement. And let's get into this. So here we're given some measurements. I'll just put some units on here: centimeters, miles. So we've got some measurements here, and we need to figure out what the precision of this measurement is, as well as the range that's allowed for this measurement within the parameters of its precision. Okay, so first thing, precision. So unless you're told otherwise, the precision is assumed to be in the last digit. So the last digit at the end of the number, that's where the precision is. And it's assumed to be plus or minus 1 in that digit. So that's if you're not told otherwise. So sometimes you might be told it's like 5%, plus or minus 5% of that measurement, or something along those lines, or maybe it's plus or minus 2 in that last digit. But unless you're told that, the assumption is that it's plus or minus 1 of the last digit. So we're not given any information, so we'll assume it's plus or minus 1 in that last digit. So here in this number, we have regular standard notation, and then we have scientific notation. It's harder to do at scientific notation because, one, it's not in standard form, and it makes things a little bit more complicated because, again, this last digit is not what it seems to be. Okay, so here we have the last digit 3. So this 3 is in the ones place. So that means that the precision is going to be plus or minus 1. So that would be the precision. So I would put plus or minus 1 for the precision of this number here, because it's in the ones place. If instead the precision was in the tens place, then it would be plus or minus 10. Or if there was a decimal here, it would be 3. Let's say if it was 3.3, then the 0.3 would be the last digit. And so the plus or minus wouldn't be plus 1, but it'd be plus or minus 1 of this digit here, which is 0.01. So this is in the tenths place. So then the precision would be plus or minus 0.1, right? But the number we're given is this number, and the last digit is in the ones place. So the precision is plus or minus 1 in the ones place. Okay. So that's the precision. Now we have to figure out the range. That's the easy part. Once you know the precision, you know that the range is plus or minus 1 of that number, of that digit there. So that means that if I add 1 to this, then the highest value that I'm allowed would be 564. So that means the highest value I would be allowed, given my range of precision, is I would add 1 to that last digit. So 564 inches, and this is inches too. And then I would subtract 1 from the last digit to get the lowest value in the range. So subtract 1 from that, I get 562. So the lowest is 562 inches. So that's the range in which my measuring instrument will allow. Anything outside of that range would be some sort of error involved, and so that would not be like a data point that should be kept. Okay, so what about these? I have this in scientific notation. What do I do? So the thing with regard to scientific notation is this digit here is not in the place it seems to be. So you'll notice that this 5 looks like it's in the 100th place, but that's only because we moved the decimal point 28 times in order to get it into scientific notation. So the placement of this last digit is not in the 100th place, it's in some other place. And so remember, the precision of your measurement is plus or minus 1 of the place that the last digit is in. So this last digit is in the ones place, so it's plus or minus 1. If the last digit of your number is in the tenths place, then it would be plus or minus 1/10, right? So how do we do this? So to kind of explain this a little bit more, I'll use a simple number. So if I have 1 times 10, let's say I have 1.0 times 10 to the third, you might think, oh, that's the last digit, that 0 is the last digit, and that's in the tenths place, and you might say, oh, the precision is plus or minus 0.1, because it's 0.1 is in the tenths place, and this 0 is in the tenths place. But that would be wrong, because we're looking at this in scientific notation. We have to look at it or understand it in standard notation. So I would write this out in standard notation like that, and this 0 is that 0 there. And so you can see right away that that 0 is not in the tenths place. It's in the 100ths place. So that means that it's going to be plus or minus 100. So I would put plus or minus 100. So it's not plus or minus 0.1 like it seems. It's plus or minus 100. That's because in scientific notation, you're kind of hiding the placement of this last digit. So you have to, one way you could see this is to write it out in standard notation, and then you can see that, oh, it's plus or minus 100. So that would be the precision, okay? But what do you do with very small or very large numbers? I don't expect you to write out the standard notation. You could do that, and you could figure it out that way, but then you got to write out, like, you got to move the decimal point 28 spaces to the left. This one, you'd have to move 18 spaces to the right. That's kind of big. So there's got to be an easier way to figure this out. And there is. So let me show you. So here's my number. I want to figure out the precision. So how did I get this in standard notation? I had to move the decimal point. So it's a negative number, not negative number, but negative exponent, right? So that means this is a very small number, right? So negative exponent's a very small number, or just small number. That means a number less than 1. Positive exponent here means that you have a number larger than 1 or larger than 10, right? So that means that I had to move the decimal point over from the left. So I was moving it this way to get the negative, right? So I'm moving it this way. So I'm making this number smaller, right? Or larger, I should say. And so every time I move the decimal point over this way, 1, I have to make this more negative by 1. So this becomes more negative when I move the decimal this way. Because if I make this part bigger, I got to make this part smaller, which means making this negative, more negative. If I move the decimal point this way, then I make this part smaller, and I would have to make this part bigger, which means more positive. But why am I talking about this? Well, in order to figure out what the precision of this digit is, I have to move the decimal point to the right of that digit and stop. And once I do that, I can figure out what the precision is by this method here. So if I move this over 1 and then move it over again, I move it over twice. So now the decimal point is to the right of the 5. Now I can figure out the precision by keeping in mind that since I'm moving the decimal point this way and making this bigger, I now have 395. I now have to make this smaller to counterbalance it. If I leave it like this, this is not the same number. It's a different number I had before. So if I move this over twice to the right, I have to make this more negative, right? So what do? this becomes 30, negative 30. So now that I have the decimal point here, I can figure out that what the precision is. And if the precision is always plus or minus 1 in that digit, but this tells me the precision here, 10 to the negative 3. So it becomes plus or minus 1 times 10 to the negative 30. And that is the precision of this measurement here. And that's how you figure that out. So again, you move the decimal point over whatever number of times you need to get it over to the right side of the last digit. And then that number of times you move the decimal point, you're going to decrease, or you're going to make this more negative by that many times. So I had to move it over twice. So I made this more negative by 2 more numbers. So I went from 28 to negative 28 to negative 30. So I became more negative for that power. And so whatever this number is the precision. So I write 1 times 10 to the negative 30. What about this one? I have a large number. This is positive. I do the exact same thing. Oh, I should before I go on, then the question is like, well, how do I figure out the highest and lowest range? Well, you go back to the original number that they gave you, and I just add again, just like I did here, to find the range, I add plus or minus 1 in the last digit, and I just keep it in this form, right? I don't need to write it out in standard notation. I just keep it in this form. And so I add 1 this digit. So the highest value would be 3.96 times 10. And I just keep, I got to change this back too. So that's going to be negative 28. And so I keep that the same. That's going to be negative 28. So that would be the highest value. And then I subtract 1 from that value. So the lowest is going to be 3.94 times 10 to the negative 28. So that's actually pretty easy, same as this. So all I'm doing is for the range, I keep the number the way it is, and I just add plus or minus that one. So I add 1 to that, and I get 3.96 times 10 to the negative 8. And then I subtract 1, and I get 3.94 times 10 to the negative 28. Okay, number 3, last one. So again, I do the exact same thing here. I can write this down on paper, or and then move the decimal point over. So here I want to find the precision, plus or minus what? Oh, I got centimeters there. So I got to move the decimal point over until it's to the right of the 2. So I move it over 1, 2, 3, 4. So I moved it over 4 times. That means I have to make this more negative by 4, right? So I'm going to subtract 4 from this since it's positive. So this is going to become more negative, or another way to think about it, less positive, right? Because I'm making this number bigger, I got to make this number smaller. And so that means more negative or less positive, if you want to think of it that way. So since I moved it over to the right 4 times, I got to decrease this by 4. So that means it becomes 14. So now my precision is going to be plus or minus 1 times 10 to the 14 miles. And so that's the precision. Now I can figure out the highest and lowest value of my range. The highest value is, again, I add plus 1 to this. I keep the 18, right? So it's 6.9562, 6.956, and then I add 1 more to that. So 3, and then it's times 10 to the 18 miles. And then to get the lowest value in your range, you subtract 1. So 6.9561 times 10 to the 18. So the lowest is 6.9561 times 10 to the 18 miles. And that's how you find the range, and that's how you find the highest lowest value in the range and your precision. So I hope this was helpful. I hope you learned something. I hope this was interesting. Thanks for joining me. Please like the video, hit that like button if you like my videos, share my videos. Please subscribe to my channel, hit the notification bell so you can be notified by any other videos I put out. And also put a comment in the comment section. Let me know what you think, and if you have any questions that I can answer for you. Again, thank you for joining me, and have a great day.